Hi friends, this is Venugopal, and the channel you are looking at is Front Benchers Tutorials VJ, and I'm going to go on with the next topic on sets, which is Venn diagrams, and let us see another topic which is quite interesting. That is types of sets. So let's go ahead. So our main topic is sets. And Venn diagrams. So Venn diagrams are basically diagrams which have been basically invented by a person called John Venn. And Venn diagrams are basically depictions, representations of sets and types of sets, which we will see in the future topics. So they're in various shapes basically. So we can either have Venn diagrams in a circular form showing the elements as A, B, C, D, E, and we can have various shapes like these also. So you can say 1, you can say 2, you can say 3. These are the elements, and we can we can name the sets as capital A. Then this can be capital B, and we can have another way in which we can represent Venn diagrams. So we can say A, then we can say have B, C, and D. So the most common ones are these the set which is shown in A, and so we'll understand how to use this Venn diagrams, how to represent Venn diagrams as we go on with the next chapters. So we'll take this in the future chapters as we learn more of sets, so that you can actually use these representations and actually depict how the sets look and how the sets relate to each other, relate to another set. Okay, so now let me just rub this part off, and we'll go to a very interesting topic called types of sets. So basically Venn diagrams are representations in which you basically draw a shape and keep the elements inside them, and display the elements inside them, and you name this. You have a name for the set, like we have in a normal. How do we represent a set with a capital letter? So that's how Venn diagrams show up. And okay, now let's go on to another topic called types of sets. Types of sets. Okay, A, we have an empty set. What's an empty set? So we can know by the name, basically the set is empty. It does not have any elements in it. That's an empty set. So, or it can also be called as a null set. This is another name for the set basically. And you can represent this null set by a symbol called phi. So this is called phi. This is how you represent it. Okay, and another way to represent in the set is basically two empty curly brackets in which there are no elements inside. There are no elements inside this curly braces. So this is a representation of the empty set. Now let's go to another type, which is a singleton. By the word you must be actually knowing. Singleton is basically any set having a single element is called a singleton set. So for example, if you have 2 as an element, a single element, or you have a an alphabet A, which is a single element in a set. So that's called a singleton set. And the C, there's another type which is called a finite set. Finite, by the word finite we mean it is a definite set. It has got a definite start and an ending. Okay. So if I want to represent a set of natural numbers between 1 to 6, this is a definite set in which the elements are 1, 2, 3, 4, 5 and 6. This is an element of the natural number for between 1 to 6. So this is a finite set. It has a proper beginning and a proper end to it. And like we also represented in our past exercise, the vowels of an English alphabet, basically A, E, I, O, U. This is a finite representation in which there is an end to and a start of a set. Okay, and then finally the D, which is an infinite set. Infinite set is also a kind of representation in which we know it's a set. Like we can call that, supposing I want to represent the set of natural numbers. So natural numbers can range from 1 to an infinite number. Infinite can be defined as, say, 10,000. So infinity, as I told you, if it is defined as supposing 100 for easy sake, for representing it properly, say our finite is our finite is 100, but or say, yeah, to make it more difficult, let's call it our infinity is 10,000. So it is quite difficult to represent this entire till 100. So we place those numbers in dot dot dot. So if it is properly defined, the infinity is properly defined, then we can put it properly as 1, 2, 3 and put it as dot 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 and say it, we can say it ends at 10,000. Okay. So but if it does not end and we say define the set of natural numbers, so natural numbers basically start from any one number to any number which is a positive integer. So it is quite difficult to represent it. So it's a set, but at the same time it's an infinite set. It goes to infinity. Infinite, infinity, both are relative to each other. Okay, what we are saying is it goes to any positive integer. So there are different representations for empty set, singleton set, finite and infinite sets. So let's see if we can put more examples for all these. Let me just rub this off. Let's write C here and just complete this one. So finite sets and set, and we have another which is an infinite set.